We do. We have 0 ohms, so that's perfect. We can probe here, and I think this also looks fine. Let's move to the third phase. 3, 2, 1, go. And I can definitely read the 1.1 volts that I was talking about. Hello and welcome. On the bench today I have a Supermicro motherboard. This is a server-grade motherboard. It's model C2SBC-Q. This motherboard is faulty, so we'll see whether we can fix it today. The RetroWeb is telling me that this is an Intel Q35 based motherboard. It supports socket T or LGA775 Intel CPUs and up to 8GB of DDR2. Now, the server where I got this motherboard from was refusing to power on. Well, it was powering on, but just for a split second, and then powering off, and it was cycling into power on, off all the time. So that seemed to be like a short somewhere. And first thing first, of course, I've removed all the boards, I've removed the RAM, I've removed anything which was connected to the motherboard, including the front panel connections, the fan, but the power supply was still doing the same. So I tested it with my own power supply outside of the case, and my own power supply was doing exactly the same. So clearly we do have a short on this motherboard, and today we're gonna see if we can identify it and potentially fix it. So let me thank today's sponsor, PCBWay, and now let's get starting on this Supermicro motherboard. Now, the first thing I'd like to do is to test this motherboard here on the workbench, because I've just taken it out from its own chassis, and you never know, there was something wrong with the chassis, something touching, a screw maybe, or whatever. So first thing first, I'll power it up as it is right now, so I can show you what it does if it keeps doing it. Bear in mind that I believe this motherboard is set to power on as soon as power is applied. So as soon as I turn on my power supply here, it should power on immediately. So let's turn on the motherboard, 3, 2, 1, go. And now the power supply is clearly going into protection mode. There is nothing connected to the board, so obviously we do have a short on the board. So many things that we can try. The first thing I'd like to try is to remove the 12 volts CPU power, because that would completely isolate the CPU, the VCORE generation. The motherboard should still kind of come back to life, but obviously it wouldn't post, it wouldn't boot. I think the fan also should run. That would probably tell me whether the issue is with the CPU or the VCORE generation for the CPU, which comes from the 12 volt auxiliary power supply here, or with the rest of the board. So let's power up, 3, 2, 1, go. Aha, yes. So this is clearly starting. This is probably telling me that 5 volts, 3.3, -5, all the small voltages which are going around the motherboard, everything is totally fine. Everything is fine with mostly everything. And the issue is probably with either the CPU or I would say more likely the... more likely or most likely? More likely the VCORE generation for the CPU itself. Next step is going to remove the CPU and have a look around. Oh wow. Well, I'm very impressed that the thermal paste of the server is still brand new. And to be honest, the whole motherboard looks brand new, and also the server looked brand new. So this is quite weird. Under the heatsink, there is an Intel Q9400. It's a Core 2 quad, and it's a 2.66 GHz CPU. Now, I'd like to power on the motherboard again with the CPU 12 volts, but without the CPU. I don't think that that's going to be very useful, because I believe that without the CPU, the whole VCORE circuit is not going to work, but I'd like to try. By the way, the socket looks to be totally fine, so if there is a short, it doesn't look it's coming from it. Let's try and power on again. 3, 2, 1, go. Yes, the power supply is still running. Obviously, there's no feedback here on the motherboard, but the power supply is still running. So I would say the issue is with either the CPU, which is kind of unlikely, or more likely the VCORE generation for the CPU itself. The CPU looks totally undamaged, so I would say let me see if I can find a spare. I might have one which should work with this board, and at that point, we will know whether we have a faulty CPU or a faulty VCORE generation. And within my CPU collection, I found this Intel E7500 Core 2 Duo. This belongs to the Wolfdale family, which is compatible with the board. So let's give a clean to the pins, which should be fine, but I'll give it a pass with isopropyl alcohol, and then we'll test the motherboard again. No, and the fan is not even starting this time. Of course, because we got 12 volts in and the power supply stops straight away. So I guess we have our answer. There's nothing wrong with the CPU. There is a fault with the VCORE generation. So that's where we're going to look into. Now, I would say this is a relatively low power motherboard. The MOSFETs for the VCORE generations are under this heatsink, which thankfully is screwed from the back. So we don't need to unglue anything. We can just remove a couple of screws. We have 3 phases. There are 3 inductors here and obviously a number of capacitors. And I'd imagine that probably this little chip here is the phase controller. So that could also be our problem. Let's remove the heatsink and see what's underneath. Right, this is quite interesting. I've never seen MOSFETs in this package. They have this metal case. Never ever have I seen anything like this. So this is new to me. All right, I've identified at least the bigger MOSFET, which is from International Rectifier. It's a 6620, and these are called direct FET because they solder directly on the motherboard in like this weird fashion where basically you can only access the drains of the MOSFET and the gate and the source is under the MOSFET itself. So it makes troubleshooting a little more complicated, but not the end of the world. Now I'm checking between ground and one of the phases, which are all connected together after the inductors, so I can only check one, and I don't have a dead short, I don't have anything that resembles a short. Now if I'm checking the MOSFETs, the case of the small ones, they're all connected to 12 volts to the supply, and they all read more or less 0 ohms with 12 volts. And the case of the big ones, it's connected to the output, to the phases. So I'm reading more or less 0 ohms between the output or the input of the phases and the case of the big MOSFETs themselves. So I don't see it like a dead short, and I don't think there is a way to check individual MOSFETs if they're all connected together to 12 volts on one end and to ground on the other and to the phases on the other one. So I think I'll turn on my thermal camera and try and power on the motherboard with the thermal camera pointing at the MOSFETs and see if there's one in particular or a pair in particular which is warming up a lot when trying to power up. Thermal camera is on, let's power on and see whether we get some useful information out of it. 3, 2, 1, go. Well, there is really not much happening here. I can see the controller is getting powered, obviously, but out of the 3 pairs of MOSFET, only this MOSFET here is getting warmish. It's now at 27 degrees. So not the end of the world. I'm not entirely sure why the MOSFET here on the right-hand side is completely cold, but some of this is actually a reflection, as you might be able to see. But what's clear is that the only one which is dissipating some energy is the one here on the left-hand side. You can see the trace is actually getting warm. Actually, I think I'm looking at the reflection, because if I'm angling the camera here, well, the reflection of the infrared is going away from the MOSFET, which unfortunately has a metal case, so it's reflecting infrared. And now if I'm looking from this angle, this perspective, well, yeah, I mean, I do see a little more activity here, but I would say the activity is more or less identical between the 3 large MOSFETs. Now the small component you see becoming red every time the power supply is trying. It's a small resistor. I think it's totally normal. Anyway, it's red, but it doesn't mean it's scorching red, because the highest temperature on what you're seeing on screen is 27 degrees. So obviously the camera is trying to highlight heat differences, but it doesn't mean this is overheating at all. And the same can be seen on the other 2 pair of MOSFETs. One is this resistor here, and one is this resistor here, which come light up every time the power supply is trying to power on. But again, they are below 25 degrees, so not really a problem. This to me sounds more like a controller issue rather than a short with the MOSFETs or the phases. So I would say that it's probably the controller is, rightly or not, sensing something wrong, and he's telling the power supply to shut off, actually. He's telling the motherboard to turn off the power supply. Let me get the oscilloscope. Let's try and take a look at those phases. See if we see anything coming up, if any of those look weird. Oscilloscope is out. Let's probe before each inductor. I'm supposed to see a pulse, and I want to see the shape of the pulse, whether the pulse is there or not, whether there's anything out of the ordinary. Power up, 3, 2, 1, go. Well, the pulse is there, it's reading 12 volts, and the shape looks okay. So let's move to the next phase. And I think this also looks fine. Let's move to the third phase. And I think this is also looking totally fine. Maybe if I want to be fussy, maybe phase 2, maybe phase 1, it's a bit sharper on the right-hand side. The other two, especially phase 2, could be my probing as well. Yeah, I'd say phase 1 looks a bit less shaky than 2 and maybe 3. But I'm not sure whether that's relevant or not. Now, the next step would be for those 3 phases to actually happen at 3 separate times. So thankfully, I have a 4-channel oscilloscopes, and these are only 3 phases. So I can see, I'd like to see them all at the same time on the screen, because obviously if I'm doing one by one, I can't confirm whether they actually happen at different times. So let me wire the 3 probes to the board, and then we should be able to see them at the same time on the same screen. I've temporarily soldered 3 pins before the inductor, so I've got 3 probes connected to my scopes and 3 channels running. Let's turn it on, 3, 2, 1, go. Okay, believe I only see 2 of them. Right, let me play with the time base. And no, they're all there, and I believe the cyan and magenta, they look a bit weird because I only have one ground lead connected. So let me connect the other 2, and hopefully they will all look like the yellow ones. And yes, they do look much better with the ground properly attached. Though the magenta one, which is phase number 2, the one in the middle, it looks higher. It's like, what's that? It's almost a volt higher. Kind of doesn't make sense. It's reading up to 13 volts, which shouldn't be possible because obviously this is delivering 12 volts. I haven't really checked how much, but 12, 12.5 maybe, not 13. It's just a bit weird that the yellow and the cyan, they look more or less identical, and the magenta one, it's a little higher, and all the parameters on the scope, they're absolutely identical. Let me swap the probes between, say, the yellow and the magenta and see whether the magenta then becomes higher or the issue stays with the probe. And it looks like the issue stayed with the probe, so that's probably telling me that my probe is reading differently. I don't know what could possibly cause that, but I don't think that that's our problem. And once again, from a phase timing perspective, I think that's totally fine because they're not touching each other. And what would happen when the CPU needs more power? The duty cycle would increase per each phase, delivering more voltage, not more voltage, but more current after the inductors through the capacitors. Now, before we move to the controller, I'd like to check a few things that came to mind just over the past few minutes. First thing first, it's whether we have like a massive overcurrent that hopefully my current clamp here can measure. That would explain why either the controller is stopping the motherboard or the power supply is sensing an overcurrent and is turning off. I doubt it because the thermal camera didn't really show much, but we can check it straight away. So let me turn it on, 3, 2, 1, go. Now, this is not probably fast enough to pick up very fast peaks, but I don't see this going over 300 milliamps. We are in DC, yeah, no more than 300 milliamps. Unfortunately, the peak function doesn't seem to be working with current for whatever reason, but it's not going over 300 milliamps. So I don't think that is a problem. And my next thought was, is it the power supply switching off because it senses a short, or is it the motherboard sensing something wrong, instructing the power supply to power off? And we might be able to visualize that. I've got my multimeter probes into the power supply ATX connector. I'm checking in between ground and the green wire, which is power on. I got multimeter in voltage mode. Let's turn it on and see what happens. And it's going at 5 volts when it's off. Then it's going to 0 volts when it's on, and immediately to 5 volts just before it switches off. So it looks like, I don't know exactly how it works, but I have a feeling it is the motherboard telling the power supply to switch off. Now, what would happen if the power supply was switching off because it senses an overload, a short or something, while the motherboard is still saying stay on? I would think you would still read 0 volts in between ground and green, and the power supply would not run because there's some protection inside. So this is kind of telling me that the controller is the responsible here. Something on the board, probably something looking after the power on sequence, is listening to the controller, and if the controller doesn't say it's all good, well, it removes power to the board entirely. After all, imagine you're running your operating system and suddenly there is an overvoltage on VCORE. The controller will send the signal out saying, I've got an overcurrent or an overvoltage. Well, what can the board do to stop it? Well, the power supply has to stop immediately. There's an overvoltage, there's an overcurrent. The only solution is to cut power. Another quick test I'd like to do is to check the VCORE after the inductor, so that should be like a stable voltage, with the max feature of my multimeter turned on. So that should tell me what's the maximum voltage that's coming out of VCORE into the CPU. Let's turn it on, 3, 2, 1, go. That's the other multimeter. We got 1.081. Now 83, but yeah, it doesn't seem to go over 1.083. And you can see down here we have, I call it, I don't know, it's called like the analog bar, if you want to call it that way. It's probably reflecting the voltage. It doesn't seem to be going to dangerous voltages. And I'd imagine for starting a CPU, 1.08 volts is probably expected. So this once again seems to be the controller telling the board there's a problem. Please turn off the power supply. So let's have a look at the controller. I had a look at the datasheet and I think I found something I'd like to check straight away. This is a post-analyzer card and these are 90-degree adapters, 8-bit and 60 bits that I designed some time ago. It makes using the post-analyzer much simpler because I can use it while on camera and you can actually see what happens. And of course it makes diagnosing the board so much simpler because you can actually see the components, you don't have to struggle to reach them. Now, unfortunately, this Supermicro motherboard is not posting, so I can't really use it yet. But even if it posted, I would have to use the PCI slot, and I haven't made a PCI 90-degree adapter yet. So that's a future project, but as you can imagine, all these PCBs were manufactured by PCBWay. Both the 8 and 16-bit adapters are available on PCBWay Store. You can place an order with a click and you're also helping the channel by doing that, or you can download the Gerber files for free and do whatever you want with it. Or if you have your own Gerber file for your own PCB project, all you need to do is to upload it to PCBWay.com. The system is more or less automatic. Just select the color of the PCB, select a postal service, and the PCBs will be delivered at your place. And not just PCBs, 3D prints, sheet metal fabrication, and CNC machining, PCBWay is the one-stop shop for all your needs. Take a look at PCBWay.com and the affiliated link is down below in the description, so if you use that link, you're going to help the channel. And let me thank PCBWay for sponsoring my videos on my channels, because their help makes these videos possible. So thank you very much, PCBWay. Now let's continue with this motherboard, and I won't need this because the board is still not posting. This is the PWM controller, it's an ISL 6322. I'm not a fan of this package because you can't probe easily, but it's better than BGA, let's put it that way. Now I had a very quick look at the datasheet and there is a pin 37, it's called power good. And I believe this is maybe not the only way, but it could be the main way for the chip to tell the rest of the motherboard VCORE is good. Power good is derived by the voltage sensors and the current sensors, and if everything is good, power good is supposed to be high. It says here that power good is an open drain logic output, so it's pulled up by resistor to 5 volts and it goes low to 0 volts when there is a fault. Obviously, power good is going to be low, so in a fault condition, during the startup, it's called the soft start. So I'd imagine there's a number of milliseconds, I guess, until all the voltages, everything is okay, and then power good will go up to 5 volts. Now, my feeling is that the motherboard is programmed in a way that if power good from the PWM controller for VCORE doesn't go high within a number of milliseconds, well, that means there is an issue and the power supply needs to be shut down. So let's have a look at that pin 37 power good. If I'm right, probably we will never see that pin going to 5 volts, and that's probably the reason why the motherboard, after a number of milliseconds, is shutting down the power supply. Now, the problem with that package is to probe things. So ideally, I don't want to probe the pins by the chip, because those will squish very easily, and then they might actually short out. So I'd like to find the component where those are connected and probe there. And pin 37, if I'm not right, is this one at the very corner. So that is great news. And I believe I should go under the microscope, but it means moving everything to the other end of the table. I might do that at some point. I believe that might be connected to that 0 ohm resistor. Number one, is that 0 ohm resistor actually working? Yes, it is. Perfect. Now, let's try and see whether we have continuity between the 0 ohm resistor and pin 37. We do. We have 0 ohms, so that's perfect. We can probe here. That is so much better. The oscilloscope is in roll mode. Let's see what happens. 3, 2, 1, go. Well, it goes up to 1 volt. It goes up to 1 volt. I definitely had the probe set in the right way. And yeah, it's 1 volt. So I'd imagine that counts as, added as a fault, or it counts as a fault. It should go up to, apparently, up to 5 volts. This is a random capacitor I have close to the controller, and it does read 5 volts. So there's nothing wrong with my probe, and it looks like we don't have the power good signal. I would say that's a very good clue. I have a feeling that this is exactly our problem. Power good is not up, something is wrong with VCORE, we need to power off to avoid damage. Alright, it's the following day, I've done a little bit of offline investigation. The first thing I wanted to find out is where that power good signal is going on the board. Now, I'd imagine that power good signal is going to the Winbone chip, which usually looks after power on and power off, and I found that this board has 2 identical Winbone chips. I'm not sure why. I mean, the Winbone is also a Super I/O, so maybe this board has more I/Os than the average. It's a server board after all. But anyways, I started tracing down manually the power good signal. And as you can imagine, this has taken quite some time, but eventually I think I got somewhere. So out of this 0-ohm resistor, I followed this trace here. I scraped a little bit of the solder mask so I can check with my multimeter, and the power good signal goes here on where this via is. I have continuity, so the signal is going at the back of the board. And this is where it comes out. I marked it with a red dot, and if I follow this trace, it's going down. It follows this trace here. There's another red dot here, goes around this hole. There's a via here, so that means it's also going somewhere else. And it's going down here. There's another via here. I put an arrow on it, and we come back to that arrow in a second. It follows here. There is a convenient test point in here, which has helped me a lot, trying to, making sure that I was actually following the right line. And then eventually this goes down and down, follows the red dot. It comes eventually here, and it continues here. As you can imagine, it wasn't easy to follow that trace in between all those traces. It continues its journey through these bunch of traces down here, and eventually ends up here to a via, and I scraped again the solder mask to make sure I was actually following the right trace. And I was. So that is going back at the front of the board, so let's take a look. Ow! Ow! This is where the power good is coming. I have 1 lead of the multimeter on the output on that 0-ohm resistor. And I have continuity, so this is where it's coming. And from here, for the life of me, I couldn't find out where else it's going. Now the trace is going behind the battery, and I used the multimeter trying to touch everything around it. I couldn't find anything. I can't see a via behind the battery. I don't really know where it's going. Also, I don't understand why it's coming this direction. What's happening here? We have the battery, we have the front panel connector, we have the SATA, we have the south bridge. I don't really know. I couldn't understand why the power good signal from the VCORE PWM generator comes to this direction. It was a dead end. I couldn't really find it. So I went back to that, or at least one of those vias that we saw on the journey in between the output of the power good signal and this point here. And this is the via in question on the other side of the board. It's going to a 470 ohm resistor, and then it goes, I don't know if you can see it, it's like a chunky trace. And those chunky traces usually means they are some sort of a rail. It means it's like 5 volts, 3.3 volts, that kind of stuff. So that looks like our pull-up resistor. If you remember from the data sheet of the PWM generator, the power good signal needs to be pulled up to 5 volts. So that's actually a very good discovery. I can check whether the 5 volts is working fine, whether the resistor is actually working, because what could be happening here is that the PWM generator, the VCORE Controller, is working totally fine. It's just the pull-up resistor, which is in charge of pulling up the voltage to 5 volts, is not working, and that's why I'm reading that weird 1 volt, and that's why whatever is reading that signal is sensing it as bad. First thing first, my resistor seems to be reading fine. It's reading 470 ohm, so that's fine. Now let's make sure that we have 5 volts on the other end. The motherboard is plugged in just with the ATX, so it doesn't power on and off all the time. And no, I'm reading 1.1 volts, which is what I was seeing on the oscilloscope when the signal was being pulled up by this very resistor. So what is this telling me? Well, it could be that the 1.1 volt is faulty. So the system is expecting 5 volts to properly pull up the power good signal to a good power good signal, but there's no 5 volts in there. So obviously the resistor cannot pull up to 5 volts because there's no 5 volts. So plan B, I started to trace that 1.1 rail, which I'm expecting to be 5 volts. And it's a bit easier to do because those traces are thicker. And the 1.1 volts is coming through this little trace here, and eventually it goes back to where we started from. It comes back here through this thick trace, and it goes to these 2 resistor networks. Now you might be able to see that 2 ends of these resistor networks is fully connected to this, let's call it 1.1 volt rail, and the other one is connected to various signals. So these are definitely pull-up resistors, but once again, they only pull up to 1.1 volts, not 5 volts. So maybe that's my problem. It's supposed to be 5 volts, it's not. So all the signals are all over the place because they're not pulled up to 5 volts, they're only pulled up to 1.1 volts. Now you might be able to see there are quite a few vias on this thick trace. They go a bit everywhere. And at some point, I got a bit lost because it wasn't simple to follow this trace. And obviously, if it's a pull-up rail trace, it goes a bit everywhere around the motherboard. So I kind of pushed my luck and I started probing continuity between that line and some big components on the board, which are usually there to generate or regulate voltages. And I was in luck with my probe on 1.1. I ended up on this component here, and I found that one of its legs is directly connected to the 1.1 rail, so I'd imagine that acts as some sort of regulator. This is the leg in question. This is an FR3707Z, and from my search online, this is a Mosfet. And honestly, I don't understand exactly how this works, because number one, I didn't know a single Mosfet could be used as a regulator. Now, there is a capacitor, but I don't see an inductor, so this is not switching. Is this acting as a switch, maybe just a power on and off, like a remote switch? If you can let me know down below in the description, because I know you can either have a regulator or a transistor, but I wasn't aware a single MOSFET could be used to regulate or generate voltage. I'm not sure, but I can clearly see that this leg where we have continuity is wired to this large plane here with the capacitor. So this looks like a power generation. Then you have lots of stitches here going to different layers. So this definitely looks like something involved with a big important rail for the board. Now the board is back on, and I can definitely read the 1.1 volts that I was talking about. Now on the other legs or pads, I have 1.2 volts here on the tab, and on the other leg I'm reading 4 volts, 3.9, and I really have no idea where this is coming from. This is where I got. And I have a feeling that this might be our problem. It's supposed to be 5 volts or whereabouts, and instead it's 1.1. And as a result, many things on the board are not working, and as a consequence, the power supply is shutting off because it's not getting some sort of okay feedback. Now, probing around a little bit, I found that the 1.2 volts going to the tab of that MOSFET is coming from this inductor here. That's it, it's a direct connection. Now, we have let me show you, there are a couple of inductors down here. We have one here and we have one here, and these are definitely some sort of regulation or generation of power, because we have 2 MOSFETs in pair and then we have an inductor, and here again we have 2 MOSFETs in pair and an inductor and capacitors. And whenever you see that, that should mean that this is a buck converter. So it's getting DC and it chops it off to a different DC. So let's power on the board and see what kind of voltages we're getting there. From this inductor, I'm getting 1.8 volt, which is the reasonable voltage that I'm totally expecting. And I'd imagine from this one, we're getting 1.2. Yes, 1.2. Now, 1.2 and 1.8 are kind of reasonable voltages. I totally expect, maybe not the regular motherboard, but this is a server motherboard. So I guess it comes with more bits and bobs, and we need 1.8 and 1.8 and 1.2. But what I'm saying is 1.8, 1.2, 3.3, 5 volts, they are kind of standard voltages. I'm not surprised by seeing these voltages on this board. And it looks like the 1.2 volt is being generated by 3.3, which once again comes from the power supply. So 3.3 goes down to 1.2, and then it goes to the lonely MOSFET, which is then generating, filtering, switching, whatever, 1.1. And out of curiosity, 1.8 volt is actually generated from 5 volts. So now I know that we got 3.3 volts going into this buck converter, and we have 1.2 volts coming out of the buck converter, which feels totally reasonable, and 1.2 then goes to this lonely MOSFET. Once again, what it's doing, I don't know, but with 1.2 volts input, well, it's kind of normal that you have 1.1 output. You can't get more than that as an output. You can't get 5 volts, you can't get 3.3. So now I'm kind of questioning my troubleshooting here, because it doesn't look like that 1.1 volt is faulty or is supposed to be higher than that. It feels reasonable to me that if you have 1.2 as an input, well, you got 1.1 as an output. You have a junction inside, it's just a voltage drop. So now I'm wondering whether I'm chasing ghosts here, because the 5 volts is mentioned on the datasheet of the PWM controller for the VCORE. I believe the sheet says that the power good signal should be pulled up to 5 volts, but I'd imagine if you are a designer of a board like this, well, you can choose the voltage that you want unless it's too high. You can go with 1.1 or 1.1. It's a very reasonable voltage to signal that power good is good, and then it goes to 0 volts when it's bad. So now I really feel I'm back to square one. I couldn't see a short with VCORE. All the pulses are totally fine with the oscilloscope. And now it looks like the power good is good, because we saw the power good going to 1 or 1.1 volts on the oscilloscope, which in theory it means it's good because it's pulled up to 1.1 volts. So this is telling me that the controller is fine and there's nothing wrong with VCORE. But yet my power supply will shut off, or the motherboard seems to be shutting off the power supply whenever I got my 12 volts to the motherboard, which is in turn trying to power on the CPU. So now I'm really back to square one, and I don't know why this motherboard is turning off the power supply. So I feel a bit lost right now, but I feel that my next step would be to look into the Winbon chips. I'm totally expecting the Winbon chip to get the power good signal from the controller. It's probably coming from somewhere I couldn't trace. And I'm pretty confident that the Winbon chip is the one controlling the power supply. So if the Winbon is the one controlling the power supply, well, I need to find out what's upsetting the Winbon chip. Now, before I dive into the Winbon chips, let me just check a couple of things, which probably I should have done as very first things, but I think it makes sense to do that at some point. Number one is battery voltage, because I know that these boards might refuse to start if the battery is depleted. I wouldn't expect the power supply to do this on and off. That's kind of an indication of a fault, an error message, a short or something, but you never know. I didn't really check. What are we reading here? No, the battery is reading 3 volts. It's kind of a low side, but that's totally fine. That's not gonna stop the board from running. The second thing would be to reset the CMOS. I know I should have done this when it was still in the server case, but let's do this now. There's no jumper to reset the CMOS. It's just a couple of pads, which just simply needs to be shorted, which I'm gonna do with my tweezers here. There we go. And let's test it. Waste of time, but it has to be done at some point. I've got CPU power back in, let's turn it on. What? What the? You're joking? Seriously? The board is alive! No, I can't believe it just needed a CMOS reset, please. I mean, this is... It's complaining about RAM. Of course there's no RAM. See, no, I can't believe this. I can't believe this. Let me plug the RAM back in, and maybe this is all it took. Turning back on. I think this is working. The CPU is getting hot, so I'll turn it off. But I think this is supposed to. Oh my gosh. Seriously? I just needed to reset the BIOS and it's working? That's so weird. I mean, the power supply doing that weird thing only when the CPU was running. Totally like telling me there's a short. Right, let me wire my capture device, because I think this is fixed. What? Oh my gosh, it's working. Right, let me turn this off because I mean CPU is now overheating, but clearly needs a heatsink. Right. So there was nothing wrong. There was nothing wrong with the controllers, nothing wrong with the phases, nothing wrong with the CPU. It just needed a BIOS reset. So note to self, next time, first thing first, reset the BIOS. It's just I was totally not expecting this kind of behavior. I would expect maybe the board not to power on or maybe to stay on and do nothing, you know, but this kind of on, off, on, off, on, off, to me, it was 100% a short. But clearly this is also an option. So that's it, I guess. What can I do? Right, let me remove the pins. Let me reattach all the heatsinks and then we'll just play a minute with this board, make sure everything works. Maybe we'll go ahead and replace the battery. And that's it. And then the video repair is done. The board is back in one piece. Let's turn it on. And I guess it takes a few seconds. And it's posting totally fine. Fantastic. Now let's have a look in the BIOS first thing first. Maybe there is a way to slow down this fan. I'd imagine this is probably set for server use. So noise is not a concern. And yes, the fan is set to full speed all the time. So let's go with quiet, because I don't care for the time being about temperatures. Save and exit. Yes, this is so much better. Right, let's see if we can run something on this board. But yeah, it looks like it's working totally fine. Now the board has 6 SATA ports, but it still has 1 IDE port. So I can plug in my compact flash. I know this is kind of a modern board for MS-DOS, but MS-DOS is simpler. You don't need to install anything. So let's see if it works. Yes, it's loading. Well, there's a character missing. I'll fix the capture device in a second. No, maybe it's not working. It's just stuck in there. And the computer is frozen. It doesn't respond to the keyboard. Yeah, caps lock doesn't respond to the button. So the computer is frozen. I don't know. Let's see if in the BIOS there's any settings that I can change for the IDE drive. And yes, of course, there are a few options, and I guess I can change that from automatic to user, so I can change whatever I want. I don't know. Let me fiddle with the settings and see if there's one which can make the compact flash to work. I know I tried everything and the system just refuses to boot from my compact flash. I tried removing the ACPI, tried all possible combinations with the IDE settings, and that doesn't seem to be working. Don't know why. I'd imagine probably I would need to reinstall the operating system on a compact flash. Now, someone on Vogons, thank you very much, suggested that I might want to go ahead and try with a USB floppy, which I happen to have. So I'm curious to see whether a USB floppy can actually boot from DOS. And it's kind of weird that the USB floppy is actually trying to boot from the floppy, but it says operating system not found. I haven't tested this floppy in a while, so I'm just wondering whether the disk has actually gone bad. I have another one here with this test RAM 4 bootable, it says. Let's try this one and see what happens. No, it's definitely trying to boot from the floppy, but it doesn't work. Okay, so let's move to Plan C. Plan C is this random SATA drive. It's 250 gigabyte with a random installation of Windows XP. See if it starts. It doesn't start. Okay, it's getting complicated. Yet another random installation of Windows XP on this 500 gigabyte SATA drive and see if it boots. Yes, normally. Okay, that's a good start. Oh, all right, I'm impressed. We are in Windows. Amazing. Now, this is a random installation I used some time ago, and I remember using Far Cry to test the motherboard. I can't possibly remember which motherboard that is. I really don't have much in here. Also, we don't have like a dedicated graphic card. I could plug one in, of course, but I just wanted to use the motherboard as it is, as it came. So let's move to plan E. I found this SATA drive, which DOS on it apparently. I couldn't remember I had it. So let's try this one because it's so much simpler. Obviously, I haven't got drivers here, and it's not going to be anything nice. So let me try and run DOS from a SATA hard drive. Yes, this is working. So you know what we're going to do to test the motherboard we just repaired. Well, and Doom works totally fine, of course. It's a modern motherboard, and Doom is nothing for this board. Well, fantastic. To be honest, despite the fact that this board was not faulty in the first place, I actually had fun trying to diagnose it, following those traces, have a look at the datasheet for the controller, inspecting all the phases, using the oscilloscope. I really had fun, and I'm kind of glad that I didn't reset the BIOS in the first place, because this obviously I wouldn't have made a video about it. It would have been like, yeah, it's working, happy days, let's move to the next. So on this occasion, I had a chance to work on this beautiful board, to be honest. It feels server grade. It's full of features, it's full of ports, and I'm sure it's pretty reliable. It's designed to be reliable and not to be, maybe not to be the fastest, but to be super reliable. I'm going to swap the battery of this motherboard and I'll put it back in the server where it belongs, and hopefully everything is going to be totally fine, but I don't see why not. Do you know why this board, for whatever reason, ended up in this non-working state where it would refuse to start? I mean, how did that happen? The battery is not depleted. I would expect a depleted battery maybe to somehow corrupt the BIOS, but I don't really understand why a board that is working one day and the following day refuses to start with this weird behavior, and all it takes is a BIOS reset. I don't know if you know anything about this. I'd be curious to hear. Just leave a comment down below. And if you like this video, as usual, I'd appreciate a thumb up still down below. And also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon. There is a free tier on Patreon, so no excuses. But if you don't want to join me on Patreon, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, that's totally fine, and I hope you enjoyed the video. That's it for today. I hope you have a great day, and I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye bye.